Welcome back. This is part two, articulating the problem. This is Steve Myers, and I'm talking about a paper I wrote for the Midwest SaaS Users Group in Chicago in 2019. Explore your data before you rush to analysis. You'll thank me later. Why do I say this? Well, if you haven't seen part one on preparation, I would encourage you to go do that. Now, what we're going to do is actually bring in a problem to solve, and we have to figure out how to articulate it. So, the problem at hand is this: are female students paying higher rents than male students, and why? So, with just that much information, and I might add that this turns out to be data on a sample of those around a college campus. The word should have been students that brought you to that. But what might we think as we begin to articulate the problem? In part one, I suggested we never start with the data, we start with the problem. And we begin to postulate or hypothesize or theorize or use common sense to get to a point that says, why should rents be higher? Not just for female students, but why should rents be higher? Well, first thing comes to mind, and they're there in order. You probably have already read them, but let me talk about some of these things a little bit. The quantity of the apartment, the bigger it is, the more likely I'm going to pay a higher rent. If I want to live in something very small versus something large, then I can expect to pay a premium for the large. So I get an idea of what that should be. Now, there's a lot of ways of measuring the size, and I'm indifferent to that at the moment. I may have to think more about how I would want to do that if I were able to actually create the data instrument to go out and collect the data. Sadly, in this case, we're going to be in a position where that's not what we're doing. We have a data set, and someone has asked for an answer to the question in red. So then we begin to think a little bit more of this, and we think, well, of course, there are preferred locations and non-preferred locations. We get this from housing, where we talk about what is the price of a house, and the most important thing we hear is location, location, and location. So certainly, where is this apartment located, I think would be an important question. And more desirable locations are going to be better. How about safety? We might want to know, is this going to be a safe place to live? Students who are risk averse may not care a whole lot about that. And students who, though, are, um, risk averse, they're going to want to pay more. And if they're a risk taker, they may be willing to pay a little less and live in a more unsafe neighborhood. How about the quality? How good is this apartment? Is it uh, outfitted with very modern appliances, or things that look so old that, one, you don't want to touch them and you don't want to use them, and you're wondering if they're going to make it through the semester? So all that's going to make a lot of difference. And we might also want to know something about the neighborhood, that the price of housing, because you don't have to live in an apartment. You could live in the dorm, so that's part of it. Or you could live in a house, maybe rent a house, or what what that housing market around you is going to affect the price. These are the kind of things that we would think. And females will pay more if they prefer 1 to 5 more than males. That's what we call an explained difference. We have 5 things here, and if we measure them, we would expect females perhaps to prefer those more than males and therefore pay higher rents. And that by itself would not be, any kind of discriminatory or whatever, that females are being charged more. It's actually explainable by the fact that those kind of apartments that females might prefer would be higher price. This is what we mean by an explained difference. So a male female gap in rents can be explained. There's your explanations. At least that's what I'm thinking as we begin to put together the problem articulation. On the other hand, after we control for all those things, we may find that there's still a gap between males and females, and that would be what we would call an unexplained difference. In other words, we don't have any way to explain that. And because of that, a gap could exist, and it possibly could be based on some kind of discriminatory uh, effect, but it may not. It may be a variable we're not thinking about. Well, here's the problem. That's the data I want. This is the data I have. So the data that I have is very different from the data I want. And even the data I have may not be exactly what I want for quantity and location, but I have nothing on safety and quality and price as substitutes. So can I do the work or not? Well, I can, but I need to understand that the data has not matched my theoretical model. My model has come out of common sense and economic theory. That's what Kennedy said when we talked about him in part one, that that was the very first rule, is we think about that because now we have to be at least humble in our work and say, well, whatever we find, there could be yet again an explanation because of safety or quality, and we don't have that information. So what we have on our data set is this. It's a sample from the campus of Ann Arbor that has rent, number of persons in the apartment, and therefore dividing those two, we have our what we're going to call our dependent variable, the rent per person. That's the monthly rent charged per person, the total rent for the apartment divided by the number of people in it. And then we have the number of rooms in the apartment. And we'll likewise want to create a rooms per person. How many on average of those rooms go to each person in terms of their individual rent. And then we have distance. Distance is the location measure. Rooms is our quantity measure. And in this case, we simply have distance in blocks from campus. So the further off we are from campus, that may have an effect on prices, and there may be an issue there in terms of explaining rents. And then, of course, we have our ubiquitous dummy variable, our binary variable that indicates whether or not the person is a female or not. So in this case, we're using the variable sex. There's no control for safety, no control for quality, no control for other housing prices, and possibly not really great measures of quantity and location, but at least we have something there that we can use. So rent should be higher as the quantity of size of the apartment increases. So the possible variable here is number of rooms per person, but we don't have square footage. We don't have square foot per room. We don't have whether you can have a private bedroom or whether it is shared. We don't have this information. So location, we have distance from campus, but we don't know if it's on a bus line. That might be a more desirable location and therefore command a premium. We don't know if it's on a bike path or students and they may want to take their bikes to campus, and that might require a premium on the housing. And we don't know how far it is in terms of commute time. We know distance in blocks, but we don't really know anything else. Under safety, you can see we don't know. Is there street lighting? Is there crime? What's the crime rate of that block? And so forth. So there's a lot of things we don't know. Well, here's our problem. We run a hasty regression. We just put in our variables. This is all of our variables down here. You see the empirical problem. We run a SAS proc reg, and our dependent variable is rent per person. Our independent variables are rooms per person, distance, being female, and of course, there's an error associated with all of these regression problems and what have you. So what do we find? We find that females in our regression pay $20 more than men. The standard error is $16 more, so it's $20.02 is the premium on rent for being female, and holding constant rooms per person and distance. But the alpha level here, the size of the type 1 error, or what some people call the p-value, is 0.23. This is not what people would think of as a good solid finding. The standard error is so large that 20 is not easily rejected from being zero. So the effect of being female is, for all practical purposes, zero from what we get in our data. That $20 does just not hold up in a statistically significant way. But the model overall, the root mean square error, is $40, and the F, the test of whether all three of those parameters are jointly zero, that is our MPP, DIST, and FEM, that test says those three variables are highly significant. An F of 5 is very, very significant in this sample size. So we have a good model, but females do not pay a rent premium. Here's the problem. Many people stop at that point. I've used all my data. I've put it in a linear fashion. Why? Because, well, maybe that's what I did in my school textbooks. They give me a number of problems and I just put them in that way. I didn't try any other kind of structural form. I didn't think of anything else. So I did that. And then I'm letting the entire weight of whether or not females pay a higher level based on one variable, the coefficient on the dummy variable, and it's insignificant. We just stop our work right here. Now, since all the examples here are in SAS, one of the things I wanted to make a comment on was there are 4 different ways to treat the variable sex. We can rename it, and I think the lazy version, often what I do is just say it should be female equals sex. We'll assign the value sex to female, or rename sex equal female accomplishes the same thing. Now, if female tells me it's a dummy variable, and ones are what the name is, female, zeros are the other thing, that would be the male. Or we could create a brand new dummy variable called female, which is if sex equals 1, then female equals 1, else females are 0. We can use labels on our variables. Our variable is sex. We use the label that you see there. So every time sex is to print out in a SAS procedure, it'll actually print female, and then in parentheses 1 equal female, 0 equal male. So it's easy to read. And we can also group by format. In this case, there's only 2 groups. There's males, there's females, 1 and 0. And every time we see a 1 for sex, we're going to use the format value, which is the word female. And every time we see a 0 for sex, we're going to use male. Now, obviously, these are put together in different places. Now, that's part 2. We've articulated the problem. We've also identified where the problems are. We don't have all of our variables. We may have omitted variable bias, which we can work backwards and try to figure out what that is. But at this point, with the data, we now have done all that we can, and we found that females do not pay higher rents. Or did we? Was that a type 3 error? Perhaps it was. So I ask you to join me in part 3, where we're really going to investigate the data through an exploratory data analysis and come up with some ideas about how to do the overall analysis in this. So I'll see you in part 3.